exponential graphs. In other words, x is in the exponent position, and they want you to graph it. These are not bad as long as you're just kind of getting rough estimates. I only make you do 3 points. Some teachers or professors might make 5. It's just a little bit more work, but no biggie. Well, like normal, if you're unsure what a graph is going to do, you can always plug in points. No matter if it's super weird, you can always plug in points. Now, typically, I stick with 0, 1, 2. Because 0 is always nice to deal with. 1, still good. 2, not too bad. So if you plugged in 0, 2 to the 0 power, 1. 2 to the first power, 2. 2 squared, 4. Now remember, these are just points, ordered pairs, or coordinates, however you want, like that. It's just there in a chart to make it easier, give you a pattern. So anyway, so 0, 1, 1, 2, 2, 4. And let's say you're like, what's going on over here? Well, let's plug in -1 and -2 if you want. 2 to the -1, remember, is just negative exponent means flip it, so a half. 2 to the -2 is 1 over 2 squared, 1/4. So at -1, we're going to be at a half of 4, or at -2, we're going to be a fourth. So notice how it's going to approach 0, approach the x-axis, but never cross it. So remember, that means that actually y equals 0 is your asymptote. In other words, your graph approaches it, but never crosses it. So it's just going to kind of swoop that way. Let's do another one. Let's say 1/3 to the x power. Same thing. You could do 0, 1, 2. So anything to the 0 power, 1. To the first power, 1/3. The second power, 1/9. So 0, 1, 1, 1/3. So, excuse me. You just kind of eyeball it there. 2 1/9. So notice how this one is swooping down, excuse me, to the right. So if it's a positive number, and for your coefficient, it's going to swoop up. A positive and greater than 1. Less than 1, it's always going to go down. This one is called exponential growth. This one is called exponential decay. Let's do another one. What about let's make it a negative. Now, if you can predict making it a negative, what do you think it's going to do? And let's see if you're right. So 0, 1, 2. So 5 to the 0, 1, but the negative's out front. 5 to the first 5, negative out front. 5 squared, 25, negative out front. So 0, -1, 1, -5, 2, way down here, 25. So was your prediction correct? Notice how it's just reflected below the y-axis. Same thing. So if this was a negative, it would just look something like that. Now, they could do weird things to you this year because the virus, we're not going to get crazy. But let's say I gave you something like this, and you're like, whoa. Well, there's 2 ways you can do it. You still start off with your chart. 0, 1, 2. But now notice how on this one, you're going to get 0 minus 1, which is negative 1. So it is a fourth. It's okay, but just, warn you for that one. Then plug in 1. 1 minus 1 is 0. So 4 to the 0, 1. 4 to the 2 minus 1, 4 to the first, 4. So when you go to graph it, 0, a fourth, 1, 1, 2, 4. Notice how it still has the asymptote, but it's like the point that was on all of these so far, 0, 1, if it was normal, it shifted over to the right. So if you wanted, you could have graphed this. Let me scoot it over to make sure you can see it. You could have done it normal, 0, 1, 2. So 1, 4, 16. Way up there. And then the negative 1, remember, if it's with the x, you do the opposite, left or right. If it's on the end, as is, up or down. So if you shifted this to the right 1, notice how you would get this graph. So you could do this graph and then shift it over 1. Just like if they gave you something like 4x plus 2. You're just going to do this graph and go up 2. So here's my original again. So you would just 1, 2, 1, 2, and so forth. And notice how this time your asymptote is going to go up to y equals 2. Where as long as you're shifting left and right, your asymptote's still at 0. Now, I know you might be like, well, why would that make a difference? Well, you got to be careful with domain and range. Remember, domain, for actually any of these, there's no restrictions. So domain is all reals. Range, however, notice how those range would be, make sure I'm on the graph, range would be, not equal to 0, sorry, just greater than 0. Range greater than 0. This one, greater than 0. This one, notice how it's below, so range is less than 0. Now this one, since we went up 2, range is greater than 2. And on all of these, it's all reals, because there's no holes, there's no gaps, there's no vertical asymptotes. So all reals for all those. I hope this was of help to you. Have a great day.